Okay guys, now we are on class 13. So before going to the inverse matrix with respect to Jacobian, I want to solve a very important problem that you have ever seen, that you saw, or you will see. That is a very important example for what? For a 3D robot. This is, guys, very important problem. You have to look at it several times until you understand, okay? And has 3 degrees of freedom. So it's 3D robot that has 3 degrees of freedom. So what I'm going to do with this robot, I want to find its Jacobian matrix. And then after find it analytically, I'm going to go to the MATLAB, okay? And I'm going to make simulation of this robot by movie, and I'm going to plot x, y, z of the end effector, x, y, z and then the vector, and I'm going to plot vx, vy and the vz of this end effector. I'm going to plot omega x, omega y and the omega z of this end effector through what? Jacobian matrix. So it's going to be very comprehensive. This class and the next class, I think it's going to take 2 classes, gonna be a summary of whatever I have done until today. Okay, so this is the robot. This is the robot. I have a joint here, a revolute joint. What the hell is this? I have a revolute joint here. Here we go. This revolute joint is being connected to another revolute joint, and this is gonna be connected to another revolute joint. Okay, this is gonna be another revolute joint, and this is gonna be connected to what? To the end effector. Here we go. This is our end effector. So I'm gonna name the length of this link as A1, this as A2, and this as A3. That's right. And this is end effector. E I'm naming as end effector. Understand? So as I taught you, this is gonna rotate around this by using the right hand rule. Thumb shows the direction of the actuation, and the rest they are showing the rotation direction. So here gonna be theta 1, because I told you it is 3 degree of freedom system. Now the other one is this, is rotating as theta 2. Here we go. So based on whatever I taught you, your thumb by the right hand rule showing the direction of the rotation. So it's gonna be, look at here guys, if you see this arrow, let me clear for you. You see the arrows, right? If you look at this way by your eyes, you're gonna see a cross. That's right. But if you look at from this way, you're gonna see what? A point. That's right. So for this joint, so first of all, let me fix this first. So this is, as I taught you, this is gonna be Z naught. This is gonna be Z naught. That's right. Oh, what the hell is this? Too much. This is gonna be Z naught. Here we go. And here we go. Let me fix the noise. Here gonna be Z naught. So this rotation based on the right hand rule, so it shows that your thumb must go inside the page. So you're gonna see the arrow from the back area. That's right. So that's what I'm showing with this. This is the Z1. This is the Z1. That's right, going inside. The other rotation in this 3D robot gonna be this. See, theta 3. Okay, theta 3. So again, see, in this direction, in this direction. So again, your thumb goes inside the page, to the other 4 fingers showing the direction of rotation. So it's gonna be what? Oh, let me change the color. as I did for here. This is gonna be in this robot, this is gonna be Z2. That's right. So now look at here, guys. This is Z0. So obviously I'm gonna say, look at here, X0 is out of the page. I'm looking from here. This is X0 out of the page. That's right. So based on right hand rule, this is gonna be what? Y0. This is gonna be Y0. That's right. On the other hand, this is like that, but I see here, this is like that. X0, Z0, and the Y0. I just showed out of the page. Understand? So based on whatever I taught you when we were setting up the Dynamite-Hartenberg parameters, so the X1 must be a normal line to both D0 and the Z1. So I'm saying that this is normal to both Z0 and the X1. That's right. So I'm going to say Z1. So it's going to be X1 based on whatever I taught you about the DH parameter. Now, based on the right hand rule, we know that based on this, you just put your thumb in the Z direction. You have to, the other force must rotate from X to the Y. So if you do that, here gonna be Y1. Here we go. Understand? So now Z2 must be normal to both Z1 and Z2. So this is gonna be your Z2. Sorry, X2. That's right. So again, using the right hand rule, put your thumb in the direction of the Z2, and then X2 must rotate to Y2. So here gonna be Y2. We got it. Y2. Now in the end effector, I'm gonna say this is your Z3. That's right. So X3 must be normal to Z3 and Z2. So this is gonna be your X2. Sorry, X3. So based on the right hand rule, so your Y3 gonna be out of the page. That's right. Y3 gonna be out of the page. Understand? So the most important step in dealing with the robotic system, this class and next class is super important, guys, because I'm teaching you 3D robots that step by step, that you have to see, like as the Baxter I have in my lab has 70 graph freedom. Okay, this is 30 graph freedom. Just you have to extend whatever I'm teaching right now to the high graph freedoms robotic systems. So the first and the immediate step is to set up proper coordinate systems. Understand? Okay, now, so on the other hand, you know that I taught you the Jacobian, because you have 3D graph freedom system, gonna be J1, as I taught in the previous class, J2, and the J3, because you have 3D, so three joint angles, theta 1, theta 2, theta 3. Understand? So we have to calculate each of them one by one for this 3D graph freedom robot. And as I taught you, because these are the revolute joints, Ji, if you look at your notes from previous classes, gonna be Zi minus 1 cross product of O n end effector. Here is n is 3, that's right, respect to 0 minus OI1 respect to this respect to 0, and the Zi minus 1. This is what I taught you exactly in the previous classes. Clear? So, and I taught you that the Zi minus 1 is rotation matrix of Ri minus 1 respect to base coordinate system in k direction. It's k direction. That's right. This is I taught you in the previous classes. Okay. So I have to find O n respect to here. Let me teach you. Here you have to say O3 respect to 0 because n vector is 3. And then you have to find J1. If I is equal to 1, you're gonna find O0 respect to 0, which is 0. If I is equal to 2, see, I is equal to 2, J2, you're gonna have to find O1 respect to 0. And if I is equal to 3 for J3, it's gonna be O2 respect to 0. So you have to find this. You have to find this, you have to find this, you have to find this, you have to find this. And then you have to find, if I is 1, you're gonna be Z not respect to Z naught. That's right. I is equal to Z1 and you have to find Z2. That's right. You have to find this, you have to find this, and you have to find this. So you have to find all of these, but as I told you previously, these you can find this through the transformation matrices. How? Here we go. First you have to find, if you want to find, guys, O3 respect to 0 or base Faraday coordinate system, you have to find T transforming matrix of n vector respect to 0. But for doing this, I taught you have to say 1 respect to 0, 2 respect to 1, and 3 respect to 2. So you have to find each of these. Okay? While you are finding each of these, you can find, after calculating those, you can find each of these, and these, and these. Okay? Let me go one by one for 3D robot. So first you have to find T1 respect to 0, coordinate system 1 respect to 0. As I taught you previously, it is a 4 by 4 matrix. Here we go. 0, 0, 0, 1. Now, let us go here. Guys, 1 respect to 0. That's right. So if you look at from the top, like this, guys, look at from the top, from both the joints. Okay, you're looking from the top. These x naught and y naught, okay, looking from the top. That's right. Let me, for simplicity, let me put x1. Oh, let me change the color. X1 like this, because x1 is also x1 is this, and I'm gonna change the y1 like this. Okay, based on the right hand rule, I want to make it a little simpler. If you put your thumb on the Z1, that's right. So now rotating gonna be x1 to y1. That's right. This is the right hand rule. The 4 other angles. Yes, it's gonna be theta 2. That's right. So because this is consistent with the theta 2. Understand? Yeah. The previous case was not the opposite direction of that. So now again, if you look at from the top to the joint 1 and joint 0, if I plot x naught and y naught, if you look at from the top, gonna be like this, guys. This is, if you look at from the top, this is gonna be x naught and y naught. That's right. If you look at from the top, that's right, because x naught is out of the page. That's right. And now x1 and y1, and sorry, x1 and the z1, because z1 is inside the page. Okay, so if you look at the top, this is gonna be your z1. That's right. I'm putting by dot because I have some intention, and this is your x1. That's right, x1. We're looking at the from the top, guys. Okay, because x naught is out of the page, z1 is inside the page. See, out of the page, inside the page. y naught is this way, x1 is this way, opposite direction. That's right. So after rotating these frame 1 based on the rotation theta 1, these z and y, they are rotating. How? They are rotating like this, guys. They are rotating like this. That's right. They are rotating like this. Oops. They are rotating like this. This is gonna be your new z1, and this is gonna be x1. For which angle? For this angle, theta 1 and theta 1. Right? Let me do this and write it. Okay. Theta 1 and theta 1. Right? So now, based on the directional cosines that I taught you, you're gonna say projection of x1 over x naught gonna be how much? Gonna be how much? Sine theta. So I'm showing sine theta with s. Theta 1 gonna be s1. Cosine theta 1 for simplicity gonna be cosine 1. And the same for 2, 3. Okay? So x1 over is gonna be, it's gonna be what? It's gonna be sine 1. x1 over y naught, that's right, y naught gonna be cosine theta 1. That's right. And x1 over what? Z naught. Look at here, guys. Projection of x1 over z naught, because it's normal to that. So this is gonna be 0. I taught you previously. Now the y. Why is this, guys? Sorry. The y is what? The y is this. Y is normal to x naught and y naught, obviously. So gonna be 0, 0. But y is parallel to, y1 is parallel to z naught. So it's gonna be 1. Clear? Now z1. Z1 projection on the x naught gonna be minus sine, minus where we are. Okay. So z1 over x naught, that's right, this is x naught, this is x naught, gonna be in the negative direction minus cosine theta 1. We are showing with cosine 1 over y naught gonna be what? Minus sine 1. So, and obviously z1 is normal to z naught. It's gonna be 0. Understand? And now transformation, guys. The origin O1 respect to O0 has a transformation of in this direction. In which direction? Z0. So it's gonna be 0, 0, and A1. Understand? Understand, guys? Only in this direction. Okay? A1. So we found that. Now, by finding this, look at here, guys. Obviously, we know that from here. We know that O0 with respect to 0 is 0, right? Because it never changes. Understand? And we understand that Z0 is equal to, look at here, this is your Z0. Z0 is Z naught is rotation matrix of 0 with respect to 0 in K, which is here what? R0, 0, K is 0, 0 and 1. So gonna be how much? 0, 0, 1. So we found the Z naught. Here we go. We found this and we found this. Okay, understand? But what is O1 with respect to 0? Okay, O1 with respect to 0 is this, guys. This is O1 with respect to 0. We got that. Understand? We got that. So, on the other hand, for J1, which is Z naught cross product of O3 respect to base coordinate system minus O naught, and the Z naught, we have this, which is 0, 0, 1. We have this, the same. We have this, which is 0. We don't have this. So we have to calculate from here. But only we found T1 respect to 0 until we get there. Now we have to find, let me change the color, T2 respect to 1. Again, a 4 by 4 matrix. I'm going step by step that you understand, okay? Because I'm gonna transfer everything and I make a movie for you for this 3D robot. 0, 0, 0, 1. Okay, now here we go. So I'm gonna assign frame 2 with respect to frame 1. So I'm gonna plot it here, guys. This is frame 1. This is frame 1. And this is frame 1. And the Z is inside the page. It's the Z, Z1. And look at here, guys. This is 2. That's right. 2 and Y2. And Z is inside the page. So I'm gonna just plot it as this is Z2 and Y2. See, this is, sorry, X2 and the Y2. That's right. Let me do this because it's rotated already. Z2 and Y2. So for which angle? Look at here, guys. So this angle is theta 3. That's right. So this angle, I'm sorry, this angle is between them is theta 2. That's right, theta 2 between X2 and Y1. So here is theta 2. And if that theta 2, here is also a theta 2. You see, step by step I'm doing. Okay. So now, X2 directional cosine respect to X1 gonna be minus sine 2, sine theta 2, because I say sine theta 2, I'm writing as S2, cosine theta 2, I'm writing as C2. See, projection on this, minus sine, over X1 gonna be cosine 2, or cosine theta 2. Obviously this is gonna be 0. Direction of this on the Z, because in Z1 is their normal inside the page. Now Y2, see, projection. Y2 over X1 gonna be minus cosine theta 2, negative direction, minus sine theta 2, obviously 0. And as you can see from here, guys, the Z2 and Z1, they both are inside the page, so they are parallel and they are normal to X's and Y's, Z, Z, and 1. Here we go. So what about the transformation between origin of this frame to the origin of this frame to be expressed in one frame? So I'm going to change the color because I want to plot it here for you. So see, you have to find in this coordinate system. See, I'm deleting this. You have to find in this coordinate system. Here we go. So origin of 2 respect to 1 gonna be a2, see here, a2 sine theta 2, right? Plus or minus in x direction? Minus, because this is positive, this is gonna be negative. And this is how much? This is a2 cosine theta 2 in the y direction. That's right, in the y direction. This is trigonometry. That's right. So you're gonna have, I'm just writing here. Come on. So let me change this a little, the border. So you're gonna have minus a2 sine theta 2, as I'm writing here, and a2 cosine 2, and in z, no. Here we go. Understand? Now, look at here, guys. Let me change the color. What is this? This is 0,1 respect to 0. We found that. Bingo. We found this. Bingo. That's right. And now, for J1 I told you, so for J2, which is Z1 multiplied by 0,3 respect to 0 minus 0,1 respect to 0 in Z1. So we found 0,1 respect to 0. Here we go. Understand? And now, let me close this. What's the time? Yeah, we have time. And now Z1, as I taught you, gonna be R1 respect to 0 in K. What is R1 respect to 0? You tell me. Here we go. Sorry guys, I'm getting older. So yeah, this is R1 respect to 0. That's T1 respect to 0 in K. So this is gonna be in K direction. This is gonna be Z1. We found that. Now we have this, we have this, we have this. Only we don't have this. So we have this, we have this, we have this. Still we don't have that. So we are closer to that. Now T3 respect to 2. We calculated this, we calculated this, now this. With 3 respect to 2. With 3 respect to 2. So what I'm doing the same. I'm plotting 2 first. This is 2. Let's see. This is 2. This is and x2, y2, and z2 is inside the page, obviously, right? And then I'm plotting this z3 and x3. That's right. So because if it comes this line, this link, I'm just plotting here, guys. See, changing the color. See, this is the link. That's right. So this is gonna be your z3. That's right. And x3. This is too much. This is x3. That's right. This is x3. And this is z3. Right? Huh? So obviously you see that the angle between them is theta 3. So here's gonna be here, this line gonna be theta 3, right? And if you continue this line, here gonna be also theta 3, right? So let me rewrite it because it's too vague. So it's gonna be x3. That's right. Now, what we're gonna do, I'm gonna say t transform matrix to respect to again gonna be a 4 by 4 matrix. Oh, did I forget? No, it's here. That's right. So now 4 by 4 matrix again. 0, 0, 0. Let me put the distance here. And a 1. Understand? So now again I'm changing the color. x3 respect to x2 gonna be, look at here, gonna be sine 3, because I say sine of theta 3 gonna be sine 3. It may take more than 2 classes for this comprehensive example of the Jacobian and its simulation in MATLAB and make a movie of this robot, okay? But when you learn this, you learn robotics basics, okay? So with respect to y2 gonna be obviously cosine 3, because look at here, yeah? Because cosine of theta 3 is cosine 3, that's right, with respect to y2. And because they're normal, so this is gonna be 0. But this cosine 3 here is positive y2, here is negative y2, so you have to put a negative cosine 3. It is positive, that's right, x. Now y2 is normal to normal into the page. Sorry, yeah, y3. So we see the x3. y3 is inside the page. Am I right? Or outside of the page? Sorry guys, outside of the page. That's right. Based on the right hand rule. That's right. It is yeah, out of the page. See here, out of the page. So it's normal to do both of these. So you see that, but so it's y3 is out of the page. Let me change the color. I want to make it come clear. So y3 is out of the page, and you see z2 inside the page. So you see that it's going to be 0, 0. So y3 and z2, they have opposite direction. So it's going to be -1. Understand? Now z3 is based on x2 is cosine, see, plus cosine theta 3. z3 with respect to y2 is sine theta 3, and z3 is normal to what? Because it's inside the page, it's gonna be 0. Understand? What about displacement between the origins? Let me show you with another color. Here we go. So the origin of this, which is O3 respect to O2, based on this, has this displacement, guys. This, see, this displacement based on the based on 2 frame. So you can see from here that this distance, look at here, guys. I'm plotting here. See, this is A3, and this is x2, and this is y2, and the angle is theta 3. Here we go. Understand that? So this gonna be how much? You tell me. This gonna be A3 what? Look at here, sine theta 3, right? Sine theta 3, right? In y2 direction. X2 direction gonna be, oh, what the hell is that? Okay. In x2 3 gonna be from trigonometry. Hold on. A2, so A3 cosine theta 3. So displacement gonna be A3 cosine theta 3 as I'm writing, A3 sine theta 3 as I'm writing here, and there's no difference z. So we got that. Now when you calculate J2, gonna be z1 sorry, J3 already calculated J2, z2 cross product of O3 respect to 0 minus O2 respect to 0 in Z2. But what is Z2? It is R2 respect to 0 in K. So what is R2 respect to 0? Here we go. This is, no, not here we go. We have to calculate that. But O3, so O3 respect to 0, we're going to calculate that. O2 respect to 0, we're going to calculate that. Now, how? First, you have to calculate this. We have to calculate this to find O3 respect to 0. Let us do that. So, T3 end effector respect to frame 0 is, guys, look at here, is, as I told you, T1 respect to 0, T2 respect to 1, T3 respect to 2. So we have all of them. We have sine theta 1 minus cosine, and let me write like this, 1, 1, 0, 0, 0, 0, 1, 0, minus cosine theta 1 minus sine theta 1, 0, 0, 0, 0, A1, 0. This is T1 that we calculated, multiplied by T2 respect to 1. Here we go. We calculate it. Then we minus S2 cosine 2, 0, 0, minus cosine 2 minus S2, 0, 0, 0, 0, 1, 0, minus A2 sine 2 means sine theta 2, A2 cosine theta 2, 0, 1. What the joke is this? And you have 0 multiplied by T3 respect to 2, which we calculated from here. S3 minus cosine 3, 0, 0, 0, 0, minus 1, 0, cosine 3, sine theta 3 means 0, 0, A3 cosine 3, A3 sine 3, 0, and 1. Here we go. Now, you have to go one by one. So, if you do that, this is what you get. I'm doing intentionally because I need all of them. So, transformation of 3 respect to 0 gonna be, here we go. Guys, look at here. This is multiplication of the first two. Why? The first two gives you what, guys? Be smart. It's gonna give you T2 respect to 0. T2 respect to gives you what? O2 respect to 0. And T2 is gonna give you what? R2 respect to 0. Here we go. This goes here. This goes here to give you Z2. So you have to have it in hand. That's right. And obviously we're gonna get this. So first go these two. I'm gonna have minus S1 S2. That's right. Because we're already having the piece of paper for saving time. Cosine 2, 0, minus S1 cosine 2 means sine theta 1 cosine theta 2, cosine 1 cosine 2 minus sine 2, 0, minus C1 minus S1 0 0 minus A2 S1 S2 A2 cosine 1 S2, you have A2 C2 plus A1 1. Here we go. So now let me double check first. Okay, hold on, I don't want to make a mistake. Minus sine 32 0 0 0 minus sine 1 cosine 32 0 0 0 0 0 minus cosine theta 1 0 minus A2 sine 1 sine 2. That's it. Now this one minus cosine 1 sine theta 2 0 0 0 minus cosine minus plus cosine theta 2 0 0 0 0 0 minus sine theta 1. Here we got and 0 and plus A2 cosine 1 S2 0 0 and 0. So 0 cosine theta 2 0 and 0 0 minus sine theta 2 0 and 0 and 0 0 0 and 0 and 0 A2 cosine theta 2 plus A1. So we got that. Now is very easy. Now you can claim that this is your what? This is what? This is O2 respect to 0. That we're gonna use in J3. Here we go. And the R2 respect to 0 is this. R2 respect to 0 is this. So its Z component gonna be this. So Z2 gonna be minus cosine 1 minus sine 1 and 0. Means minus cosine theta 1 minus sine theta 1 and 0. Understand? Now this multiplied by, because again this is your T2 respect to 0. This multiplied by what? By T3 respect to 2. Here we go. This. So this multiplied by S3 0 cosine 3 A3 cosine 3 minus cosine 3 0 sine 3 A3 sine 3 0 minus 1 0 0 0 0 0 1. So the result of T3 respect to 0 gonna be a huge matrix that I'm gonna simplify. So you have to multiply one by one. Okay, so let me do that because I want to double check with you again. This by this gonna be minus S1 S2 S3 plus S1 cosine 2 cosine 3, right, and 0 and 0. Now 0 0 cosine 1 and 0. Now here minus S1 S2 cosine 3 minus S1 cosine 2 sine 3. You know that each of these means what? Sine theta 1 cosine theta 2 sine theta 3. That's right. 0 and 0. Now these terms gonna be minus A3 S1 S2 cosine 3 minus S3 sine 1 cosine 2 S3, and finally minus A2 sine 1 sine 2. This is the first row. Let me double check with my notes. Sine minus S1 S2. Sine 3 minus S1. Sine 3 minus A3. S1 S2. Cosine 3. Sine 1. Cosine 2. Minus A2 S1 S2. That's right. Now second line. Gonna be. Let me see. Oh, we're exceeding the time. Let me copy from here because I trust myself. Cosine 1 S2 S3 minus cosine 1 cosine 2 cosine 3 S1 minus cosine 1 S2 cosine 3 plus cosine 1 cosine 2 S3 minus SA3 cosine 1 S2 cosine 3 plus A3 cosine 1 cosine 2 S3 plus A2 cosine 1 S2. Third row, third row is cosine 2 S3 plus sine 2 cosine 3 0 cosine 2 cosine 3 minus sine 2 sine 3 A3 cosine 2 cosine 3 minus A3 S2 S3 plus A2 C2 plus A1, the last line 0 0 0 and 1. Let me double check the third verse. So I can A3 cos 3 minus A3 S3. Finally gonna be A2 as well. Okay. Now this is your, we'll have to simplify this in the next class to find O3 respect to 0. We are in the beginning of the problem. To find this, that we're gonna use here, we're gonna use here, and we're gonna use here to find the Jacobian. We are at the beginning of the problem yet. It maybe takes more than 2 classes, but this is a very comprehensive problem, guys. We have to focus on this, and you have to learn this. A 3D robot moving in 3D space and with 3 degrees of freedom. Okay, we're gonna continue this problem next class.